CPUs are the new constraint because of people like us and sandboxes and RL environments and all these things. And by October, there will be no more CPUs. Like, it's done, like for this year. When you think about why people use your product, there's three ways. One is awareness. Do they know you exist? Two is preference. And then the third is like, is there some deterministic factor that you have that others don't?
You're listening to the Kubelist Podcast, where we explore how AI is reshaping the infrastructure underneath it. Each episode of this podcast is a conversation with project maintainers building the tools that make AI run. Hi, I'm Marc Campbell. Together with Benjie to Groot, we host this podcast and write the Kubelist newsletter. I'm the founder and CTO at Replicated, where we enable our customers to operationalize and scale the distribution of their modern on-prem software. Check us out at replicated.com. Benjie is the co-founder and CEO at Shipyard, where they enable agents and humans alike to validate their code and manage ephemeral environments. Visit or send your agent to shipyard.build to get started with ephemeral environments. The Kubelist Podcast is brought to you by Heavybit, the leading investor in enterprise infrastructure. For more information, visit heavybit.com. All right, welcome back to the Kubelist Podcast. Today we have Ivan Burazin, co-founder and CEO of Daytona, to talk about sandbox environments, which are really growing in popularity. Really excited to talk, Ivan.
Likewise, great to be here.
One of the ways we love just to get started is to kind of hear your background, like think back to the early days when you started using computers, kind of like start there and we'll kind of build the story.
Sure. Like video games were always the start of things. And so mine was an Atari. Actually, that's sort of like aging myself here. So that's where I started and always wanted to build out video games and sort of get into computers. And then you end up, what's the thing? You start with video games and you start doing B2B software after that. Sort of directionally, not exactly what I say we because me and the co-founding team of Daytona has been together for quite a long time. And so we actually started doing a bit different. We did do programming, we did websites, we created our own CMSs back in the day, late 90s, early 2000s. But where we actually created a first company was actually stacking, data centers and server rooms. And so that's sort of like the origins of where we started. Basically, there was a opportunity in the market. We did that. And we did that for a few years and ended up selling that company. And the reason we did is we actually my co-founder stumbled onto a new idea, which is a browser-based IDE, right? And so we created I believe, the very first browser-based IDE in late 2008. So a very, very, very long time ago. I understand that the co-founders of Heroku were probably the first ones to do it, but then they pivoted to Heroku, but we were the only ones that ended up doing it for a long, long time. And so we sold that first business to focus on that. That was super early. But the interesting thing was the first company we did was, actually physical servers, screwing them together, networking, virtualization, all these things. And the second company we did, the Code Anywhere, was, there was no VS Code, so you had to create your own editor. There was no Kubernetes, so you had to create your own orchestrator. The isolation layer, I think Docker had just come out, but we were using something called OpenBZ at that time. So we had to build a lot of the things ourselves. All of these things sort of pile into what we're building on today.
So Ivan, I want to go back for 1 second. Where did you build the data center stuff? Where did this start? Was this in Croatia or was this?
This was in Croatia. So as we talked in the beginning, so I was born and raised in the suburbs of Toronto, and parents are Croatian, hence I'm Croatian. And in Croatia, was working for high school, did university, and started my first job and my first business. So stacking these servers was in Croatia. And Code Anywhere was in Croatia as well. So even Daytona was basically founded while we were here. In the meantime, we had lived in the States. In the meantime, flew a lot back and forth, a long time in Boston, then a while in New York, and now ultimately in San Francisco again, just because that is where, everyone building AI agents is. And so it just seemed like a large opportunity cost not to be there. So yeah, it was in Croatia, to answer your question.
So you were racking and stacking. So this is like early data center stuff in, I guess that's Eastern Europe?
Mm-hmm.
Okay, yeah. And I know that just from a little historical standpoint, obviously there was the war in the late 90s. And so Croatia kind of had this renaissance after that. And so I know that there was a big animation, like outsourced animation thing going on in Zagreb at the time, I think. So who was using your data centers and like how big were they? I just think it's really interesting, where we have terawatt data centers coming online versus, you probably racking and stacking like 3
data centers on the moon.
Yeah, it was much smaller. It was much more humble than what we're looking at right now, right? And so these were, for the most part, like CPU boxes, which is interestingly enough is what sandboxes are for the most part. And so again, like Dell and spinning up VMware and whatnot, the consumers of this were usually like banks and large telcos and things like that. To be fair, just for the Croatian history here a bit, right now there's about 3 companies worth over $1 billion in Croatia. One of them is Infobip, which I worked for a while. They acquired one of my companies, which is a direct competitor to Twilio. So they do a little over $2 billion a year right now. They're based out of this village in Croatia, which is interesting. Then you have, for the people, the car lovers here, Bugatti is now a Croatian company, just if no one actually knew this.
I thought it was French. Isn't Bugatti French?
It was until a Croatian company acquired it. So one of my friends, Mate Rimac, one of the fastest hypercars in the world, his company Rimac Automobili actually acquired or merged, or I don't know what the technical part of it, but he is the CEO of both companies right now. So if you see, people driving a Bugatti, that is now under the umbrella of a Croatian company. So that's an interesting one. He has a second company, which is called Vern, which is a self-driving car company, which is also, I think, valued over $1 billion. And then we recently, I think it was like 2 years ago, Google had just acquired one of Croatian startups called Photomath. The public numbers didn't come out, or was order of magnitude $500 million or something like that. So there's a bit of things happening in a country that is, for people that don't know, 3.8 million people. So it's actually quite small a country.
I love Croatia. I've been there a few times. One of my favorite spots. But I think the interesting thing there is, like you said, it's 3.8 million people, and you're racking and stacking data centers. Obviously, you said banks and stuff like that. So I would assume a lot of that has to do with, PII and EU regulations. But this is early. This is 2005, 2006, 2007.
Yeah, you're right. Actually, it started, I think, 2004, 5, something like that. Yeah.
Wow, that's really cool. Okay, so how long were you doing that? How long were you building out data centers for?
I think it was about 4 or 5 years.
And then you went straight into a cloud IDE in 2008.
Yep.
Was it web-based or was I open source?
Web-based, yeah, web-based IDE. So think like Replit before what Replit is today, or Codespace is what existed. So we built that in the early 2000s and went full on. I think 2013, we got like an investment from like Techstars in Boston, and then we moved there for a while. And then that's sort of where we kicked off the sort of like Silicon Valley learning about what investors are, how to grow companies and things like that. So yeah.
And building that had to have been like super different, right? Like somebody doing it today has the advantage of VS Code in Monaco, and like it's like just drop an NPM component into a website and you kind of get it, right? Like, so you're building this the hard way. VS Code.
We built the whole thing, yeah. And interesting part, it's like, oh, we were competing against, I don't know what, Sublime Text or whatever it was, and VS Code did not exist. And then it's like, oh, we need plugins. It's like, oh yeah, how do we create a plugin ecosystem like that? Like you just solved syntax highlighting and connecting to all these different things, remote sort of like box to get this up and running. So yeah, we built it all internally. So it was quite different. And also the speed of things was quite like you could mess around for like 3, 4, 5 months and try to figure something out. Like today, you don't have that opportunity. Like if you don't do it, someone else will. And there was no AI, of course. Like, so you had to do it by hand.
I mean, this was JavaScript. That predates Node, I think, some of that.
Some of that does. So we started using Node at some point, but yeah, it was very new at that time.
Wow. So 2013, you moved to Boston for Techstars for this web-based IDE. You said that you kind of got introduced to VC life, North American, how to grow a company, all that stuff. What happened to the code editor company? What did you learn? How did it become the next thing?
Sure. I mean, we learned a lot of things, like what is a user, what is a buyer. By the way, to be clear, like DevTools as an investable market really wasn't a thing that much at that point in time. After that, I think it was 2015 or whatever it was, when GitHub got acquired by Microsoft for $7 billion. What was it?
9.5, I think.
9.5. There you go. I was in the ballpark, right? I forgot the number. But anyway, after that, it's like investors were like, oh, you can actually make money from DevTools. So that was quite early. The other thing is we sold directly to the end developer, which is not how you make money. You have to sell to businesses and developers have to bring it in. So we didn't have that. We didn't have an on-prem solution, which was quite interesting for that time in the world. You had to have that. So we learned a lot of things on that. Like it made revenue, the company itself and whatnot. We raised a bit of money, but we didn't know how to tell a story, a vision, connections. We didn't understand how human network effects actually make a difference when you're raising capital. And so we learned a lot of that in a very, I should say, hard way. We, for better or for worse, were quite stubborn. So we pushed that on for quite a long time. It just wouldn't die. I mean, it still exists. Someone else runs it, but it still exists. Right? It's still alive somewhere in the internet. So it's interesting that a company like that The interesting thing that you also learn is that even though something doesn't seem actually dead, it actually, it might be dead and probably better off to move to the next thing. And so all of that stuff was applied in Daytona when we did it. Like we actually pivoted at one point in time. We're doing pretty well. And we're like, no, this is not the thing. Kill it. Like literally kill it. Move on to the next thing.
What year did you guys sell that company?
I mean, we sold it fairly recently, like a few years ago. It wasn't that much. We kept it for quite a while. We ended up paying back our investors. We had like Techstars and a handful of angels that put in money. There was like $1 million invested in Code Anywhere. And so we paid all of that back. And then it was just like, it generated a bit of revenue. And so it just stayed for a while until we decided to, move it to the next thing.
Tell us who else is on the team, because it sounds like you guys have been together for a while.
Yeah, so my co-founder and CTO, Vedran, has been with me. Like we met while I was still doing the data server stuff and then data room stuff. And then we had created the Code Anywhere company together. And then our first engineer, Goran, who's now our like chief architect and third co-founder of Daytona. And then after Code Anywhere, I ended up creating this developer conference and that got acquired and sold. And then we came back together, the three of us, to do Daytona. So me and Vedran have been together since officially working together since 2008, but known each other for a longer time. So we're talking like 2 decades there. And then Goran is probably a few years less with us. And then the entire team of Daytona right now, there's a few new ones, but the vast majority have worked with me or them in our previous ventures. So the average tenure of working together in Daytona, or I should say the mean, is probably like 6 years, something like that. So it's like a high context, high throughput organization because we've all known each other for a very long time. So there's a lot of, FUs and whatnot, but in the loving and hating way. So that's great. I think that lets you move faster.
Yeah, it definitely does. And you're all distributed in remote.
We have 3 offices actually. So we have an office in Zagreb, an office in Split, an office in San Francisco. So people are all in office, but in one of those 3 pods.
What year did you start Daytona?
3 years ago now.
3 years ago. Okay. I'd love to hear like a quick explanation of like what Daytona is, and then kind of go back to like the inspiration, the origin, like why you decided this was a problem you needed to solve 3 years ago. It seems kind of everybody's doing it now, but like 3 years is a long time, like a lot of, insight and foresight into building it.
Sure. We didn't start like this 3 years ago, so we'll get into that. But basically, Daytona, the product now, is what the market calls a sandbox provider. But what we are trying to serve or enable is composable computers for agents. And why I say composable computers, first, I think of it as a computer in general. Like as humans use computers, agents will use computers. It's not just for code execution. It's for like installing applications, for doing all these things. We can get into use cases. But it's essentially, if a human needs a computer to do something, there's a high probability that an agent will need to do that as well. It's not exactly one-to-one, but there's a high probability that it will be. And then I say composable because as humans, you have different computers for different use cases, right? So you might have like a MacBook Air for like answering emails and traveling. You might have, this big GPU-enabled Windows machine to do 3D rendering or whatever it might be. Like you have different use cases, different computers for different use cases. And so we essentially enable an agent or the system for the agent to say, oh, for this use case, I now need, 4 cores, 16 gigs of RAM, and a Windows operating system. Or I need a Linux operating system and a GPU inside of it. Or I need whatever I might need. And Daytona will spin up that configuration in, depending on the operating system, but for Linux, it's like 60 milliseconds, which is half the time it takes you to blink. A Windows operating system takes about 1 second to get up and running. And so there's different speeds depending on what you need, but essentially enabling an agent to do the task that is at hand.
Does that include GPUs in this world, or are you guys mostly CPU?
Yeah. So we're mostly CPU based. We're introducing GPUs now as well, but it's a different use case. So it's not GPU for inference. It's like the reason why you have a GPU on your computer. So is it like 3D rendering? Is it, playing a video game? Is it like whatever you have a GPU for on your computer? And again, there's some computers that just have an onboard, whatever graphics processor used in for whatever, but then you have like a big one for something else. So if you're using Blender for 3D animations, you probably need a GPU to get that done, right? And so you need a sandbox or a computer with that enabled inside of it.
So it's really like the compute that the agent wants to be able to do something on. And it turns out the agent already has an inference provider because that's how the agent is running. So
exactly. The inference provider is essentially the brain of the agent or whatnot, or the agent itself. It's not the agent, but the brain of the agent. And if the agent has to do a job, then it spins it up. So it's equally like the three of us are now in front of our own computers. It's the equivalent of that. It is literally just that, right? And so I digress right now, but what I'm doing is trying to spin things up. And I now have a sandbox with Mac in front of me right now, spun up, and I have a phone and I have a SIM card in it. And I'm actually connecting all that for an agent, has its own email, has its own account, it is literally on the Daytona. Like we have now agents in the org equal in the sense they have their own privileges, what they can and cannot do, but you can essentially like text them, message them, Slack them, email them, whatever, and they go off and do the thing. And so as we start thinking about agents as digital humans or digital knowledge workers, it becomes more and more clear to people why we need these, as we call them, sandboxes.
And agents might be relatively long-lived. You might have an agent that's like monitoring, whatever, like doing some infrastructure task. It might be like monitoring signups on the website, but the compute that the sandbox environments Daytona is providing are very ephemeral, designed to be relatively short-lived tasks, or are they longer?
No, they're actually the opposite. No, so actually Daytona, when we were building out Daytona, we can talk about the story as well. We actually thought of it first off. Ephemeral sandboxes came as there's a flag for it to be ephemeral, but that was like a second order thought. Like our idea was it has to be like a human computer, meaning it has to be stateful and long running. So meaning it should run as long as the agent wants. Like it can run forever. There's no stopping it, right? Unless someone kills it, turns it off, the agent kills it, whatever it might be. It has to be stateful. So like we open and close the lid of our laptop, it's the same state. You want that same thing. And it has to be super fast. And so those three things together was the foundation of what we thought an agent needs and the foundation of what we built at Daytona. That's why for the orchestrator of the sandboxes, we don't use Kubernetes or anything off the shelf. We rewrote our own to be able to do this. We do use Kubernetes for the deployment of the control plane and things like that. But for the orchestrator itself, we don't actually use it because we thought it was insufficient for having those three things working at the same time.
So we're going to dive in. I want to dive into that in a second. But before we do, you said you started 3 years ago. I mean, I think 3 years ago, sandboxes for AI agents were probably maybe a twinkle in a few people's eyes. But I assume that
no one.
Yeah.
No one.
Yeah, I don't think so. What was the original idea behind Daytona? Like, obviously, you've evolved to here. You guys have gotten a lot of traction. But talk us through, I mean, you made a good point earlier where you're talking about like identifying when something's not working and moving on from it, even if you think it's sort of working. So talk to us about how it started.
Sure. So we started Daytona as a spiritual successor to Code Anywhere. We ended up pulling out what we had learned on the orchestration layer that we did for the cloud IDE. We had found that a lot of the tech companies had built something internally similar for their agents. So if you work at like Netflix or Google or Meta or whatever, you have this automation to set up your dev environment, right? So it's very, essentially one click. You don't have to like spend 2 weeks setting up your dev environment, which you have to do in all the other Fortune 500 companies. And building what we built or learned at Code Anywhere, we said, oh, this is an opportunity for us. There's a story how we got actually involved in that by accident. It ended up being we had specific domain knowledge in spinning up these or orchestrating these VMs. And then we had started selling to some like Fortune 500 companies this product. And so the original product, again, is just like for human developers to automate their dev environment, not locally, remotely, but securely. And we ran that for about a year and a half pretty well and growing pretty well. But what happened was end of 2024, this is 2026, right? So end of 2024, people started talking about AI agents. Devin was available in like private beta. There was this competitor called OpenDevin or OpenHands, and you had to install it locally on your machine. And I'm like, you know what? I was talking to my co-founder. I'm like, this actually doesn't make sense that you're running this locally. This makes zero sense to me because you can fire off multiple tasks, but you're constrained by your machine with the compute and CPU you have. Plus, if you close your laptop, it doesn't work. Like, it doesn't make sense. I have the same analogy today when I see people running Claude Code locally. I mean, it's fine, but you can't, work as many as you want. If you close the lid, it stops working. And I'm like, maybe we can use our thing. And we sort of bashed together our dev environment manager, what we called at that point, the original Daytona, and OpenDevin, or now it's called OpenHands. And we got so much inbound from people building agents. They're like, oh, we need to set up our environment for our agent. And this was like before it was cool. I believe that the following February, so like 6 months after that, at a conference in New York, both OpenAI and Anthropic had announced the new specifications or new definition of agents, including a runtime or a dev environment. So the following February, the model companies publicly said this was a thing. And so we were ready. So to your point, like 3 years ago, no one was talking about this. 2 years ago, still people weren't talking about this. And then as people started like reaching out to us, we gave them what we built, and they said basically like we can't use this. And there we discovered what the differences were between how you set up a VM or a runtime or a dev environment for a human and what agents need, right? So you need an SDK, it has to be super fast, it has to be stateful, all these things. Some of them were assumptions, something we sort of like grokked from the people that we're talking to. And what we did is we made a prototype of that over the holiday season, me and my co-founder, and we booked 22 calls with the people that were reaching out to us, the few months earlier.
Right. This is 2025 holidays.
24 on to 25, yes. 24, yeah, on to 25. And so January of 2025, we have 21, 22 calls. Every call goes long. Every call. People are literally emailing us afterwards as like texting us, give me the goddamn API key. Like, I'm not lying. This was insane. I never felt this in my life. And I'm like to my co-founder, you know what? This is it. And if it actually seems true that the number of agents in the world will be the number of humans to the power of n, which people weren't sure about at that point in time, it's like, this is sick. And no one owns this market. Like, we have to go. We literally, at that point in time, put all hands in the company, said, the old thing's dead. We helped all our customers migrate to competitors of our old thing. And we just plowed on this thing. Like, we basically, our GTM team, as most were in Croatia, went to San Francisco, started creating awareness around this product. The product is basically an MVP. It runs on like one VM, right? The engineering team goes to build it. And so we're building momentum the next 3 months, the go-to-market team, while the engineering team is actually building this product. And then we launched this product sort of 3 months later with the audience already sort of ready for that. And in that meantime, from that January to that, I think it was like end of January to end of April when we launched it, was when like OpenAI, Anthropic then announced that this is a thing. People started announcing it was a thing. And, it's sort of like, it was a timing thing.
Yeah, Cloud Code beta, I think, was April of 25. I think so, right? Cloud Code beta?
I think it was like February
25. So timing is everything.
Timing is everything.
That's spectacular, obviously. That feeling of product market fit is, I've read about it a lot. Marc and I have read about that. We talked to a lot of people that know how that feels. We're still working on it. But wait, so I just want to understand, let's talk a little tech turkey for a second. You had this orchestration layer, and that was for VMs. Was that Firecracker with the original product, or was that not Firecracker yet?
So we used Firecracker at that product. Yeah, we used Firecracker for that product. And we learned a lot of things. And so like the way we attached storage to these things was interesting, and it was very slow. And so we had to use Longhorn to attach storage, and at scale, that's really hard. And so when we decided to do these sandboxes to make them very fast, so this is what we do. And our thing is open source, so people can see this. Basically, we're like, okay, we want like, sub 100 millisecond spin up times. How do we do this? And so Daytona Sandboxes, unlike any other VMs and any other sandboxes, actually uses the CPU, RAM, and hard disk of the underlying node. So we don't attach external storage. You're using the storage from the node, because most people use like a RAM CPU of the node, and then you attach external storage. And just the attaching of storage takes time, and the throughput is also slower, right? And so we're going to do that together. And so the way Daytona does it really fast is, if you imagine our like stacks of, we run this on bare metal servers basically, but we can run anything. It could run on a VM, but for a lot of reasons we run it on bare metals. And so if you imagine, all the Daytona bare metal servers, basically what we do is the snapshots or the history or the point in time or the template, whatever you want to call it, to create a sandbox is actually preloaded on the SSD disk of the node. And then when you fire off, I want a sandbox with that snapshot, it actually goes to that node where it is. And from that SSD to the same one turns on a sandbox, right? So there's no network latency connection. Everything's actually on that node. Now, of course, we can't fit every snapshot on every single node. And then so you have an algorithm that you sort of source them out onto different nodes. And then you have sort of layering of snapshots as well to compress them. So there's a bunch of things that we do there. But that was actually quite exciting and interesting to build that out. And sorry, when I went into the technical part of the conversation already, but this is sort of like the things that we sort of do.
Let's kind of go back to the product. I think it's just some definitions would make sense. I've used Daytona a little bit.
Sure.
Like, you're right. It's almost magical. You create a sandbox, and like by the time you get your bash window back, like the sandbox is running and you can SSH into it. There's never like a latency loop or anything there. But You mentioned sandboxes and snapshots as two terms, right?
Yep.
Can you kind of define what those are in the product?
Sure. So a sandbox, you essentially think of as like a container, a VM, a micro VM, whatever you want. Like the industry calls them, we call them sandboxes. And so I'll tell you what I think of a sandbox. And then so there's no term right now because today sandboxes, people offer sandboxes that are just like app layer isolation, that are just bash, that are like a full VM. They're like, they're different things. None of these tools are bad. It's just like there's different definitions. But what we look at as a sandbox at Daytona is we look at it on two axes. And one is the primitive axes. So it is the actual, let's call it VM container sandbox itself. So how fast can it spin up? Can you pause and resume it? Can you fork it? Can you put multiple operating systems on it? Can you dynamically change the CPU RAM configurations? Can you add a GPU? Like those are things that we look at the primitive level. And the other is the tooling axes. And so the tooling is, one, we started Daytona thinking that agents should have all their tool headless. So we come pre-baked, and coding agents were original customers. So you have, an FS tool completely headless. You have a terminal that's completely headless. You have, a Git client. You have all these things already baked in there. But you also have things like a firewall, so you can define where the agent can go outside the sandbox or not. And then upcoming is like a secrets manager and then a process firewall. And so we also add a layer of tools that on one side help the agent get the job done faster, but on the other also add guardrails, potentially the agent. And so that together we call a sandbox. And the definition of a snapshot is basically, it's either a memory snapshot or a file system snapshot. It is like the state of the hard disk and or the state of the memory and the hard disk of this sandbox.
So a snapshot is like, you could use it to like pre-bake a bunch of stuff in so that you spin up a sandbox and it kind of comes up quicker, so you don't have to do a bunch of runtime installation, boot time installation.
Exactly. So the whole point is like, so when you spin up a default Daytona sandbox, it comes with a bunch of tools, but ideally you probably have other tools that you want. So then you as a customer can like create your own snapshot. You can just pull in a Docker image or something like that, and so you say, oh, this is what I want, and then we preload that snapshot into our system, and then it becomes super fast, just like ours does.
So Benjie asked a little bit ago if you were using Firecracker. Interesting, because you said we were.
Yeah.
So like you're not now. Does that imply then you're no longer using Firecracker?
Yeah, we will and we won't. So we will again. And so we actually started Daytona using Docker hardened with sysbox. And so when I say Docker, people are like, oh, it's a container. It's like unsafe and whatever. So Docker has this product called sysbox that also gives you isolation equal to a container, more or less. Like we've done multiple like security audits and whatever. It is
equal to a VM. Sorry,
equal to VMs. Yeah, it's equal to VMs. Yeah. And so Docker helped us do a lot of things really, really well and really, really fast. Now, that being said, we also have a Firecracker. We also have a cloud hypervisor, and we also have a Kimu. We're not using it at all anymore, but we have it up and running. So basically, depending on what you want and what type of sandbox you spin off, you'll actually get a different isolation layer underneath. The customer doesn't know this for the most part, and actually shouldn't know this because they don't really care. And so to answer your question, like for the Linux one, we started off with Docker because it let us do all these things very, very fast and move fast. Again, I know there's some competitors that started after us, but from the perspective of the incumbents, if you can call them like startups as incumbents in the space, like we are the last ones that came. So it's like, this was the ultimate way to move fast. And it ended up being a really, really good tool for a large set of our use cases or customers, which actually run RL workloads. And so for them, and we can get into customers in a minute, but basically the input and output is a Docker container. And so having that super like natively and fast enabled them to get a lot of things done.
So basically an OCI image is kind of the input and output.
Exactly. I mean, you can use that for the others as well, but then we have to sort of like bake that into a VM image in the background so you don't notice that. But this was very like natively, right?
Okay, so it started with using the Docker stuff. And I know that secure stuff, I looked in that a while ago. That stuff's really cool. But now you said there's multiple layers here. How do you determine who gets what? Or is it just based on OS?
No, it's based on spec. And so it's like CPU, RAM, and disk are not a spec, but a spec for us, but we can put that in there. So it's like CPU, RAM, disk, GPU, operating system. And so depending on what you fire off, like the first three don't matter because it's all the same across of them. But if you flag on create, and so the multiple operating systems and GPUs aren't GA, but we have like customers already using them. So basically, if you fire off a request to create with that in it, then we know which one to create in the background. We know which isolation layer to use. So right, GPUs doesn't work on all, like on Firecracker, you can't use, or on Docker, you can't use a Windows or you can't use a GPU. Like it doesn't work at all. And so for now, there's some issues. You can run Windows in a cloud hypervisor, but there's no graphics driver. And so you can't use remote desktop, I believe, or VNC. One of the two doesn't actually work if you use a cloud hypervisor. But if you use a QEMU, and a QEMU, it actually does have like a quote unquote display, and they can render that display as well. So there's like technical reasons why we have one type of them for the other. There's also drawbacks, like some of them are faster or slower, or the way they like load from hibernation or pause to resume is super fast on Firecracker. It's QEMU, it's really slow because you have to load the whole RAM, the memory back into RAM to turn it on. Whereas on Firecracker, like there's a sort of like a lazy load type thing where it can sort of like kick it off very, very fast. So there's different trade-offs to each, but we're trying to give the customer the ability to have all these computers together.
Yeah, you mentioned that it takes about a second for Windows VM to turn on.
Yeah.
Just going to say, I don't believe you. No, I'm just kidding.
Yeah.
But how in the world are you doing that?
Oh, yeah. So the Windows VM, by the way, a Windows VM takes like 2.5 minutes to boot and then another 30 seconds to get up and running on the clouds. Like it's very slow.
I feel like that's generous. I've seen it more like, in my experience, more like 5 minutes for those things.
Yeah, it's very slow. And so we did a lot of work on this. And so we have a hypervisor that's not Windows. And so we run it on a Linux hypervisor. And so we do a lot of like dark magic in there to get that up and running. And so, yeah, it is just about at a second right now, spin up times. So we're super proud of that. And customers are like insanely excited about that. By the way, Windows, for the most part, we can look back at this maybe in 6 months, but people still think we're idiots for doing that. Like, why the hell would you need a Windows sandbox? But stay tuned. I have insights on this.
Well, I will share my insights on that, and you have some stuff coming, so we'll leave it at that. But I think it's pretty obvious that, you know, for Office and for all these agents that are running, that are coming, especially when you start talking about training and like real world stuff and like back office and all this other stuff, obviously the Windows thing makes a whole lot of sense. That's why the 1 second thing is mind blowing to me. Can you share a little bit of technical details on how you do the 1 second Windows thing? So you're saying there's a Linux hypervisor that loads memory of Windows. Like, is this Windows 10 or what? I don't even know what Windows.
It's actually, so the Windows what we're using right now is Data Center Edition, because from a licensing perspective, that works. And we can downgrade it to a Windows, whatever, 11 or whichever the Windows is right now, but it actually costs quite a bit more. So we'll leave that up to the users if they actually do need that. But the Windows Data Center Edition has the ability to look and feel exactly like another Windows. So it's essentially Windows. It's the same. There's just like more things inside of that. So that shouldn't bother the agent, right? And so when you include, memory snapshot and the way we manage these machines, which is also similar, RAM, CPU, disk, all on the same underlying node and things like that. And we've done a lot of new things with expanding the memory. We used to have, I digress slightly. We currently on our product have a constraint on size of hard disk because you're actually constrained by how much hard disk you can have in a physical machine, right? That's why most people use an external external like EBS or something. And so we've now actually sort of like conjured a solution to have like unlimited hard disk while still being at the speed and throughput of it sort of being local. And so that will help as well. But I can't give you all my secrets, but yeah, that's there.
But you don't have to be constrained just to that disk, right? You all do support like fuse mounts and external mounts on those sandboxes.
Yeah, but fuse mounts are slow as hell. Fuse mounts are slow, right? So fuse mounts, we have our own product called Daytona Volumes, which is essentially an S3 fuse mount. And so the cool part of that is that all the credentials are inside of Daytona itself, so your agent can't see that, and it's part of the SDK, so you can like fire that off quite easily. But the problem is a fuse mount, it's just slow. It's super slow, and you only use a fuse mount if you want to read large data, and then that's fine. And so you're like in a terabyte of data that you want to sort of load in there, but you're not going to do like your workspace directory inside of a fuse like that. That doesn't work.
So that's where like the RL workloads might come in for folks leveraging Daytona. Okay, so you guys are using these SSDs. So do you guys have your own data centers yet? Or are you using Hetzner or Vultr? What are you guys using?
So not Hetzner or Vultr. I mean, it's somewhat you can see on our subprocessors Hetzner just because we have a few of them running to test stuff out. But basically, all this, again, it's public on our DPA. You can see that. But we're using mostly co-location providers that we can order servers per specification, and then they give us those specs and then give us access to them. And so, yeah, it's like we have our own data center, but we don't have the complexity of that.
But you actually own the hardware that you're putting in those colos.
We pay per month on this. Just like from a financial standpoint, it doesn't make sense to invest the long-term capital into that. But we do have contracts to keep them up and running for amount of time. We could buy them out for how much we're paying over time. But working as a startup, it just feels more optimal to rent them out and then sort of figure out where we sort of expand from this. And so do we end up building our data centers? I believe so, but we'll see.
And hopefully you have ways to mitigate against RAM prices 10xing and stuff like this.
No, CPU prices, guys. CPU prices. So we have semi-analysis. So Dylan Patel from semi-analysis does all these analysis on prices, GPUs. Like GPU is the constraint, CPU RAM is the constraint. He was also at our conference. We just had a conference recently at the Chase Center in San Francisco called Compute, and he was one of our guests. And he was talking about CPUs are the new constraint because of people like us and sandboxes and RL environments and all these things. And by October, there will be no more CPUs. Like it's done, like for this year. So
buy what you need now.
Exactly. Yeah.
Well, yeah, I mean, that makes sense. We need space-hardened CPUs soon, apparently, which may or may not be a smart idea. Who knows? I don't know how to cool those things, but yes. Okay, so you guys have co-locations there. Did you start off co-located? I mean, I'm just interested in this because your background of racking and stacking, I feel like this is a big advantage for you guys.
Yeah, for us, it made sense. Like our thought process is the following. If we're going to build I don't even think like AWS is a competitor. They certainly don't care about us at this point in time. But in the sense of like, if you want to build out like a large cloud company, I find it very hard to believe they're going to do that on top of a large cloud company. Like that sort of like defeats the purpose of those things. Plus, the only reason that we have a right to exist at all is that the software stack that we had built out is our own. And so we're not offsetting anything to AWS's or Azure's or anyone's else software stack. Because if you can do that, it becomes quite trivial to actually build this product. Hence, you don't need the product, right? So and so if you think about it, that the way I think about it is like, okay, we have to be able to do that from day one. And so if we're going to go into that, we might as well just do these co-location providers because we're going to run on our servers anyway. There's no difference. It's now, if it's our own data center versus this, it's a server. Like there's no software stack on top of that you become dependent on. On top of that, there's the gross profit margin part, which is much better than running this on clouds, but also performance. It's not huge, but you do get like a 10% performance hit if you do use this on top of the software stacks on top of the cloud. So, performance is better
for the AWSs, but Hetzner is not like Hetzner is bare metal.
It's bare metal. You could do that as well, but there's other things. It's like so now you have the DevOps overhead, right? And so like you now have to spin up. We just have shy of 1,000 servers now running, physical servers now in Daytona, right? Just shy of 1,000. And so we spin up a lot of these servers. And if there are different configurations, different size, different date, different whatever, then the setup time is just like a pain in the ass. And my DevOps people will be just like, they'll bitch. And they're like this just takes time to do that. Whereas the benefit of doing something in the cloud, like the only benefit of using a bare metal in the cloud is it's usually always the same machine, which means that you, one, have an API to spin up the bare metal, and then two, it's the same machine, so your scripts will work right out of the box and you get it up and running right away, right? If you use something like Hetzner, you don't know what you're getting, right? It's like different machines, different days, different, like some of them are older, some of them are newer. There's like, it's all over the place. So like we'll spin up sometimes something like that to do like tests or like something that we're trying to POC or whatever, just because it's like quick and easy to get them up and running. But the standardization of them is not ideal. And so that's why you want a sort of co-location provider that is at some level that can give you standardization and speed of deployment of these boxes.
And it even goes deeper than that. I've replicated, we built something on top of Firecracker to create micro VMs for our customers. It's not a competitor to Daytona or anything. It's a very purpose-built thing. And we actually did it on top of Hetzner. The challenge is Hetzner only offers bare metal in Europe, not in the US. And so if I can spin up a VM in 60 milliseconds and then the latency is like over a second for keystrokes on SSH, it's like unusable still.
No, that absolutely. So that's why we have regions as well. We have we have the providers that have multiple regions. And I did actually, you're probably correct, although I thought they had it in the US, but I hadn't looked at it. But there's other things. But yeah, I would agree as well. You want it to be where the consumer is.
So you have data centers around the world?
We have 5 locations now, yeah.
So in North America, Europe?
Yeah, East Coast, West Coast, Europe, Asia, and one more in Europe. So we have 2 in Europe, 2 in the US, and 1 in Asia right now.
And in the product, do I specify the data center, or do you just like geolocate it?
Yeah, there's like region. Yeah, so there's regions in the product right now. So we haven't, because we're migrating some things. You basically have an EU and US like flag right now, and Asia. So you have those 3 flags which you can do. But I think in about 2 weeks you'll have like East Coast and West Coast, and you'll be able to split between. Right now you're like randomly between East Coast and West Coast, which is not ideal. I can totally get that. So that's not ideal. And so we'll segregate the 2 of them, and you'll be able to choose which one you want.
So capacity planning is something that I'm going to. How do you, like you said, you went from 0 to 1,000, literally in this case, 0 to 1,000 servers. But
Yeah.
how in the world do you know if you need 2,000 servers next month?
You don't. Capacity planning, like now that we've been around for a while, we've been like Daytona's been live, this product less than a year. So like end of April. So, we're coming on 11 months now. And now there is some data and figuring that out. But right now it has been, we have like obviously measurement utilization of where we are. But there's a couple of things you have to think about, right? For capacity planning. One is like, what is your growth rate, right, of your company? And so if you look at your growth rate, let's just pick a number. This is not our growth rate. Let's pick a number, 20% month over month, whatever it is, right? And if you're like saying you're growing 20% month over month and you want to keep the same utilization of your servers across, then you'll keep stacking 20% more each month, right? Like kind of trivial way to figure that out. And that's fine. Then when you add on that the spikes of usage, because the way we work, because we're an infra company, like we're more like, a Twilio and a Stripe than other types of companies. Whereas like someone will integrate you and then they ramp up their product. And then if their product's successful, then they just like spike, right? Then they just go vertical. And if they go vertical, you go vertical. So you have to be prepared for these jumps in customers. And basically, if you look at our growth trajectories, it's like linear growth, then like 5x, then it's linear, then it's like 5x, then it's linear, then it's like 5x. And like, so you get these big customers that sort of make that go up. And you have to like always have in the back of your mind, okay, I have to make sure that I can have capacity for these. And then it's more like, oh, what does our pipeline look like? Who are we talking to? Who's like signing a contract right now? And then you can sort of like feel that out. We've been wrong. We've like overbought sometimes and underbought, but like ballpark, we're sort of feel that out. But the other part that's also very, very hard to manage is RL workloads. So if you look at background agent workloads, where audio, so people can't see this, background agent workloads do the day-night weekend thing. So like in North America, during the day it goes up, during the evening it goes down. And then in the weekends, it goes down, Monday and Friday are the least, Wednesday's the highest, right? And that's your peak. And then you tilt that if that company is growing and sort of how that grows. And so they're not spiky workloads. You can sort of like calculate what they have. But if you look at the workloads of RL, it's like a square. It's like flat up to 100%, whatever they have utilization, use that for 5 hours and then down, right? And so they like come in and they spin up 50,000 concurrent, like 50,000 concurrent. That means you have 50,000 CPU cores somewhere. Like that is not a trivial number to have of CPU cores, right? To have somewhere up and running. And so you have to have that for them. So your capacity management is like, what is my growth rate? What is my growth rate for these types of customers? And then what do I have to do to serve these super spiky customers that come in and they use it for a while and then they're gone. They use it again and they're gone. So it is a non-trivial problem to solve.
So what do you do? What do you do? How do you handle the square?
You overbuy for a lot of things.
Yeah.
And so it's also like how when we talk to our, especially RL customers. So the way RL customers have their need is like they usually have GPU allocation for a while. And then for their GPU allocation, when they're training models, they actually need CPUs in that same time. And they want to make sure that those CPUs are very, very fast, because you basically want your GPU running, if you're like in car analogy, you want it at like in the red RPMs, like you want your GPUs always running in the red. And then your CPUs, as they spin up and down, because you can spin up, hundreds of thousands through these runs. You want, when you kill one, you want the other one to come back as fast as you can. And so that's why the speed thing comes really interesting. And you want to be able to serve these customers. Luckily, they at least know like a day before they need that, which is not a lot of time, but like it's not live. So you have some time to have capacity management and say, okay, customer X, here you go. And then if customer Y calls up, it's like, okay, there's a lot of still like hand planning of like enabling limitations for this. But the thing that we want to do and we're really proud of is for RL workloads, our competitors will take like anywhere, let's say 50,000, they'll take anywhere up to like 30 minutes to get 50,000 sandboxes up and running. Daytona takes 75 seconds to get that up and running. So 50,000 takes 75 seconds to get up and running. And the way we do that is obviously the throughput that we have, but because we quote unquote own the metal, we don't have to provision VMs when you're asking, we have them idly and then we spin them up. Now, there's a whole conversation of like, how do you get maximum utilization where that works? And if you want the VC answer, I have all these answers for that, but like that's basically how we solve that right now.
Oh boy. So you have a lot of computers sitting around is the answer.
Yes.
So in October, when I can't get a CPU, I got to come to Daytona.
Exactly. That's the point.
Yeah. Well, I look forward to having conversations with you in 6 months and seeing what that 1,000 server number is. The RO workload stuff is super interesting. So people are leveraging you guys for that. So there's the consumer side of this, or I don't know if it's consumer, but people using Claude Code and Codex inside of these things. And now you have these large, model folks, I guess, using you for, or whoever, using you for RL workloads as well. So one thing that I think is super interesting is your SDK and your CLI. And we're running low on time here, but I do want to touch on those and just talk to us about, like, you go to Daytona's GitHub and it's 70,000 stars and it's got, a pip package to install. Tell us about the SDK. Tell us about the CLI. I've heard very good things.
Oh yeah. I can talk about that. First of all, we have to clarify is most people think on our GitHub stars it's just the CLI because that's on the README, but it's all of Daytona. The whole thing is there. So hence, like so if you want to spin up your own Daytona, it's a AGPL3 license, so there are some restrictions, but the whole thing is there. Someone said we're like too open source. I've heard a competitor say we're too open source. So a lot of things there. So it's not just the CLI on its own, but the SDK or the CLI, but that's what we put on the README because that's just most people use. And so we will redo that so people can actually see the whole thing is in there actually. And so that's why I wanted to, like, before I get into like the SDK and CLI, that's the reason why you have so many stars, if that was the question. Like the SDK, it's all on its own, I feel, and you guys are on the outside looking in, so you probably have a better vibe of this. We think it's actually really good. The SDK especially, the CLI has a bit of polish, but the SDK we feel is like, we're really happy. We've had a lot of like positive comments on that, and we try to make that as good as we can for humans and agents actually integrating this in it. So I don't know if that was your question directionally.
No, not at all. The stars, I think it's cool. It was just more, I've heard great things about the CLI and the SDK. How do folks use it? What's the way? But now I didn't realize, like, backing up for 2 seconds here, what is Daytona? Is it Go? Is it Rust? What is, like, obviously we can go check out the GitHub, but like, what is it?
There's a lot of Go. There's a lot of TypeScript and a lot of Go in there. So there's some other things, but like that's basically what it is. So the orchestration stuff is mostly in Go because we've always been sort of like, we as a team have done that and used that, and TypeScript for like the app layer stuff. And so that's what most of the code is.
I feel like, I spent a lot of time writing Go code. Most of Replicate is written in Go, and y'all have a Go SDK, an official Go SDK, which is unusual in like the AI world. Everything is JavaScript and Python, and I'm like, oh, this is nice.
There's a couple of things that we think about, and so I'm sure that all competitors will be listening to this, so this will change. What you're sharing is like, when you think about why people use your product, basically, there's 3 ways, right? And so why someone use you? 1 is awareness. Do they know you exist? 2 is preference. So preference could be anything. Pricing, design, the person you met that works there. Does it have a Go SDK, right? Like, it could be whatever. Like, the preference is very, very wide. And then the third is like, is there some deterministic factor that you have that others don't? So like is it a government contract and you have FedRAMP and like they can only use you, right? So those are 3 things, right? That's there. And so I think we're probably the best in our market and wider market of go-to-market. Like, we've been on this for the last 10, 11 months, and it's just been insanely growing. And then when we look at, okay, so what can we do from a go-to-market, not even technical perspective, like what can we do from a go-to-market perspective that someone will prefer us versus someone else? And even though like agents do a lot of the coding today, there's still humans doing a lot of these integrations are integrated. And so to your point, Marc, is like, if you're a Go developer and we have Go and our competitors don't, if all other things are equal, you're probably going to pick us, right? I'm not saying all things are equal, but like if they were, then you pick us. And so what is our time investment to get that done. And for me, that made sense. And so we also have Java coming up, and we have .NET coming up and whatever. And we wanted to make sure that everyone sort of is supported because, to your point, everyone's either just Python or just TypeScript or those two and nothing else, basically.
Yeah. I mean, that's cool. I want to move on. I think early on you said you wanted to talk about some use cases. I'd love to talk about use cases. I think that you described it as, this is computer use for agents, right? Agents can spin up computers that can perform all these tasks. The startup time isn't just a vanity metric. We're faster than everybody else. It's like super important for an agent to be able to do this without having to do some awkward polling or async callback to is this machine running or failure rates. So the agentic flows, or the agent use cases, let's talk about some of the use cases you see out there.
Sure. We break it down into 2 use cases, and then there's multiple ways to use it. The agent uses it. So the 2 basic use cases are what we call background agents and we call reinforcement learning. So background agents is essentially, your Ramp launched this product. You probably saw that, like the internal product of their agent, doing coding in the background. They don't use us, they use a competitor, but in that sense. Or you have Mintify is a customer of us. So Mintify now generates docs on the fly. Their agent does that. To do that, they spin up a Daytona sandbox to do that. So we're engraved in that product, but it's an agent that does something. It spins up the machine, the sandbox, it does what it needs to do. It kills the sandbox, and then it submits the code. So for the audience here, if they've ever used like Claude Code in a browser or ChatGPT, whatever, and you say, oh, go, analyze this data or search the web, or not search the web, but it opens the agent tab, it actually spins up a sandbox to do that. And so that's like the background agent use case. And the other use case is RL, reinforcement learning, which we talked about, so I won't do that again. But both in those use cases, the agent can do what we call coding commands execution, computer use, and browser use. So there's like 2 ways that agent does that, which is like that sort of headless way. Is it firing off like a command in the terminal, using a CLI, running code, executing a script, whatever it may be, or calling a whole GitHub repository? That's the coding command execution. And the other is like the computer browser use. Is like, does that agent actually need to use this because there's legacy software that it needs to use, or it's doing QA or whatever it may be? And then it goes and use that. And so that's how we think about the 2 use cases that are broken down in 2 modes of work.
Got it.
So Ivan, we're running low on time, but I really want to talk about the company building side of this for a minute, because obviously like you said, you went from 0 to 1,000 overnight. We keep talking in these ridiculously small time frames. Like, oh, I've been doing this for 11 months. And it's like, what are we talking? Like 3 years ago, that was like, okay, yeah, you just started a company. In today's day and time, like you're the gray beard of Sandboxes right now. So you obviously were a VC funded company, and then you found this product market fit. You went bonkers with it. I believe this is public information you guys raised around recently. Just tell us what happened that's appropriate to share, and then what it's like juggling customer demand, raising money. You have actual CapEx that you need to deal with because of the model that you explained, where you're buying. You're
renting, but yes, yeah. So yeah, first what we did, we raised a pre-seed on the old product, $2 million. It was mostly just like founders. And so we have a bunch of cool founders in there. And that the old product, it was closed sourced. And then we decided to open source that product or a version of that product for the single developer. And then we were able to, we had revenue even on the pre-seed. And then we had revenue kept growing after that. But we decided to open source it in March of, whatever it was, 24. That product, and that went like bonkers. That went like 4,000 stars in 24 hours. Where I forgot it was like very, and that actually kicked off our seed round, because our internal investors, which were mostly angels, there were some like funds that put in small angel checks, and they were like, "Oh, we want to give you money." Basically, that was the conversation, and that stuff does happen. They text you, and they're like, "Oh yeah, we'll do that, and we'll kick off a round." The funny thing is, some people say that, and they don't actually mean it, and now they've thrown you into this like fundraising mode. And anyway, so we did close a round in like 3 weeks. So we ended up doing a 5 million seed round, which is great. Upfront Ventures led that round. And then we kept the story. Now, what happened of like, pivoting and changing and whatnot. And so then we launched this new product, and we go from like 0 to $1 million run rate in like 60 days. It was like insanely fast. I mean, there's faster today, but it was like pretty fast for us, pretty shocking. And then
In the old days, 11 months ago,
in the old days, yeah.
0 to $1 million ARR was huge. Now it's kind of
That's whatever. Yeah, exactly. Yeah. And then we went to 3 in like 45 days after that. And so basically what ended up happening, this isn't part of the public, but basically our internal investors basically doubled down and gave us like uncapped term sheets, uncapped safes to put in more money inside of Daytona, which we on an uncapped safe absolutely did take. We're like, thank you very much. We love you guys so much. We will take this, right? And so that was great. That gave us more money in the bank. We're okay because we had spent a bit. We were running for like a year and something at that point. So that made the whole thing better. I did tweet about this, but I don't know if it really resonated with people. We ended up then, after we got that money from internal, said, oh, like we're awesome. Now our internal investors gave us, what was it, like $7 million or whatnot. And like, oh, we'll just like close an A round now because we're freaking awesome. Like these guys gave it to us. And we go out to try to raise an A. We talked to everybody. We got one term sheet, which was not very good. And we decided not to take it. And then we went back to work for 3 months. And then actually, which was my young self wouldn't have done this. And this is sort of anyone listening. I called back like all the VCs and said we didn't raise a round. And so obviously whatever you say, they think you just suck, right? Because like we weren't able to. So there's a lot of ego here where you're like, you know what? Here I am again. And then we show them the numbers 3 months later. And then, you get 4 term sheets, which end up being like, there's a whole process. It's stressful. It's not that easy. But in the sense of like, it was like, we did a pre-seed, which was like kind of okay to do. We did a seed. It went fast, but there was points that we thought it was going to like fail. Then we had this little round in between that was part of the A. And then the A, we failed the first time, like flat on failed. Like, you guys suck. Go back home.
And that was when you went from 0 to, you went out the first time 0 to 3 million and you failed?
No, it was right after the 0 to 1. And then between the 1, it was between the 1 and the 3.
Oh, okay.
And so, yeah, it was between the 1 and the 3. And then by the time we got to like, after it was 3, and then we did some work, another month or so, then we went back and said like, let's go do this. And so we didn't do the whole thing. We called maybe, I don't know, 10, 15 people on that one. And that one closed pretty fast with a bunch of term sheets. But like, it sounds easy now, but it was like hard. Like you have to like literally go home beaten. Like they beat you. You did not come home with the term sheet.
Yeah, what I've learned is dealing with rejection is like basically what being a CEO actually is.
That's it. Yeah.
It's just like, thank you so much. Will you buy my product? Can I hire you? Can you give me money? It's like, no, until they say yes. So, okay. So you raised, if it's public, what you guys raised?
It's right. So 24 million total was the A round, 5 was the seed, and 2 was the pre-seed.
When did you close the A?
We signed the term sheet in December, closed mid-January somewhere.
Okay, so like 2 months ago, you closed.
Yeah.
Oh, congratulations. Well, it's been 2 months. So have you done the B yet, or what's going on here? What are you doing?
Maybe we've got something. We'll see. Yeah.
Well, you need money for CPUs. Come on, get in front of that.
Yeah.
So juggling the fundraising with the growth, I'm just going to assume that was not a fun experience.
It's not fun even now. Like I have to it's very flat. It's 25 people as of today or yesterday in the company. And so I'm very not pro hiring. I'm not the one that says, oh, like a vanity metric, I want to have like 100 people. I don't like the less people, the better. There's less complexity between the team members. We all still like each other. Not, all the things of a small company. But like we literally at this point in time, and so we're talking to investors on this. And so we haven't even hired any sort of sales org. And so we've closed like Fortune 500, like very, very, very large companies without this, like enormous companies without this. The amount of inbound that we have now cannot be solved anymore without hiring. Like I'm just falling apart. Like I honestly feel, before this podcast, I'm like, can I say no to this? I just have so much work, but I want to do it, right? So it's just like insane. And so managing that, board members, the capacity management, all the things, I'm not complaining. It's just like,
no, it's crazy time.
It's great. Like I love it, but just like it'd be great to have 2 hours of sleep, and that's it. So yeah.
Well, Ivan, I think that this is the story of Daytona. It's just, sounds like we're just at the end of Act 1 right now, and we're gearing up for Act 2 for Daytona. the RL workload stuff, I didn't realize that that's what you guys were kind of the next step, which makes a whole lot of sense. So that's really exciting. So there's an open source project. Typically, historically with Kubelist, we like to promote open source. And is there contribution opportunities there? How does that work?
Absolutely, there is. So, the repository is Daytona.io/Daytona. And so there's contributions can be done there. Also like security. We also like bounties on security bugs. If people find any of them, they can submit that there. And so they can use it there. Anything that, as any open source project, they're more than welcome to contribute. Obviously, it's not the product itself is like directed by our customers in the company. But if anyone would like to or has reason to or enjoy to, we're more than happy to have them.
And you said it was AGPL?
It's AGPL, yeah.
Yeah, cool.
Ivan, this was amazing. I was so looking forward to the rest of the year for you guys. Thank you so much for coming on. Really enjoyed the conversation.
Thank you for having me, guys.
And that's all we have time for today. If you're building infrastructure for AI and would like to be a guest on this show, head over to Kubelist.com. The Kubelist Podcast is brought to you by Heavybit, the leading investor in enterprise infrastructure. For more information, visit Heavybit.com.